So, hey everyone, uh, let me check, just for some moments. Yeah, and hope so. I am audible. Just give me some moments. We will start in 1 to 2 minutes. Just so, yeah, we're live. So, good evening, everyone, and welcome to our station on statistics for AI and ML. I'm your host, Hasnul Banna Himel. Today we will have some, we will spend some awesome time together in this station. So, what are we going to do today? We will explore the foundational role that statistics plays in artificial intelligence and machine learning. Throughout this session, we will discuss the core statistical concepts, methods, and how these principles are applied to develop and fine tune data driven models. I am Hassanul Banna Himel and I represent AI ML NLP community Bangladesh. So now let's dive right in. So this presentation is designed to help you understand the significance of statistical thinking in the context of AI and ML. Statistics enables us to analyze and interpret data effectively, which in turn forms the backbone of model development, testing, and validation. We will cover essential topics such as descriptive statistics, inferential statistics, and regression analysis, and explore the real world applications of these methods in data driven modeling. Uh, I want to share my whiteboard with you now. Uh, just hold some moments. Yeah. So I hope that you can see my screen now. Uh, yeah. So let's start now. So we all have a question, right? That what is statistics and its applications? So if you wonder, statistics mainly is a field. Statistics is a field that deals with collection, organization, analysis, interpretation, and presentation of the data. So, in statistics, we mainly deal with a bunch of collection of some data. We work with some organization data, we organize the data, we analyze the data, we interpret these data, and we present these data. So, why is it so mandatory, or why we need this? In one word, it is mainly needed for decision making. So, if let's assume I have a bunch of data. So let's say, in example, let's say I have a bunch of age, and this age are the people who do the online shopping. Do online shopping. So let's say I have a bunch of ages. Let's say I have ages of 23, 14, 17, 25, 32, 45, let's say 30. So what we can do with this data? We can do many things. Let's say we can find the mean from this data. We can find median from this data. We can also do some distributions. We all know different kind of distributions used in our email, right? There are fields like there are Gaussian distribution, there are and many more. There are various kinds of distributions. There are like many. So now also with this data, what we can do with this much data, we can create charts. Let's say we can create charts. If I have a bunch of data, let's say here you can see here we have many data, right? We have 23, we have 14, 17, 25, 32, 45, 30. Let's say this is a tiny data, right? When you are working in ML, you will see thousands or millions of data, right? So it will be hard for you to calculate or how to solve these issues. So what we can do, we can create various kinds of charts. Here we can create charts and graphs. We can create charts and graphs. So, do any of you have any questions? Do let me know. So, we can do many things. Like we can create a histogram. can do histogram, we can do the PDF, we can do the CDF, and many more. So let us draw a histogram. Here, let's say there's one bar, there's another lines going side. Sorry for that. Let's say this is a histogram, right? So when I draw a curve from, let's say, from here, I have a curve, say, yeah, something like this. This was a histogram, and this one is called video. So why is it necessary to like work with data or work with the statistics stuff? Mainly, it is useful for us to understand the data, understand the data. If once you understand your data or what are you working on, it will be easier for you, right? Like let's say for our previous example, like I have a product, I have a beauty product, or I have a bag which is targeted for the audience, let's say range of 20 to 30. When I have a bunch of data, I can see, right? Let's say I have a bunch of data where it shows that, let's say these bags are mostly needed for the age in the women's between 20 to 30. So here you can see from the data. Let's assume this is our data. Let's assume this is our data. Let's assume this one is our data. If want I want to, let's say you are a market analyst or a data analyst. You want to share the percentage of people who need this bag. Let's say this is a bag, this bag from you. And when you are done with analysis, you can see that, let's say this is age range of, let's say 30 to 35. Let's say this is something like 15 to 20. This is our the desired one from 20 to 30, and so on. So here you can see that this percentile of people are wanting this bag. So it will be easier for you if you want to sell this or you want to provide this to anyone. So from this you will know like who is your desired customers. So now I will get back to my slide. Yeah. So we're back to our slide. So what we have seen that statistics enables us to analyze and interpret data effectively, right? We have seen the example with the bag, which mainly forms the data development. Like you were building a model and you were like looking for, let's say, we all know Amazon, right? We all know Amazon, we know Daraz. When we buy something or when we add cart, add do some stuff in add to cart, you have seen that like people is also getting this with this. Like if I am going to buy let's say I'm going to buy a t-shirt or a shirt, they can show that people are also buying this pant, or they're buying this hat with this, or some glasses with this. So that is how they interpret the data effectively to provide you with your information. So here's an outline of what we're covering today: the importance of statistics in AI and ML. Number two, our key statistical concepts from data summarization to regression analysis. And number three, the integral role of data in modeling. By the end of this session, you will have, hope so, have a strong grasp of how these techniques are foundational for building robust AI and ML solutions. Now, let's start by discussing how statistics is so critical in our field. Essentially, statistics provides the framework that helps us make sense of data. Every decision we make as data scientists or machine learning engineers depends on an understanding of data patterns, probabilities, and uncertainties. Whether we're building algorithm or validating their performance, statistical methods ensure that our approaches are rigorous and our models are grounded in data. We have some, yeah. Now, before we move into our application specific methods, we must cover the basic building blocks. Key concepts include descriptive statistics, our inferential statistics, probability theories, regression analysis. So, what is our descriptive statistics? These are tools that helps us summarize and describe features of the data such as central tendency and dispersion. Uh, I have some other videos too on this, like central tendency and dispersions. And what is our inferential statistics? Methods for making predictions or inferences about a larger population based on a sample of data. And what are the probability theories? Critical for understanding randomness and uncertainty. And finally, we all know the regression analysis. It is foundational to many predictive modeling techniques. Together, these principles form the basis upon which many AI algorithms are built. We all know that data is the core of AI and ML, right? Not only do we need high quality data, but we also need a thorough statistical analysis of that data to ensure that our models are both accurate and reliable. In this section, we discuss how proper statistical analysis is essential for everything from cleaning the data and transforming the data into a feature engineering and model evaluation. Now, let's begin with descriptive statistics. Measures of central tendency. Here we have our mean, median, and mode. help us summarize the typical value within a dataset. For example, help knowing the average or median value of a feature can quickly tell us about the general behavior of the data. This is crucial, especially when pre-processing data for machine learning, as it helps us understand underlying disturbations and identify potential anomalies. Just a few moments. Yeah. So, what is variability or dispersion? Understanding variability is key. Measures such as variance, standard deviation, and interquartile range or IQR allows us to grasp the spread or dispersion of data. This understanding is critical in assessing risk and uncertainty, determining model robustness, and identifying outliers. Visualizing this data using tools like box plots or histograms can bring clarity in this concept. Like as we seen before, these things like in the histogram we've seen this brings us clarity to this concept, right? Making it easier to interpret the variability in your dataset. Now, visual representations make statistical information more accessible, right? Let's say effective visualization techniques like histogram, box plots, and scatter plots are invaluable tools. They allow us to uncover patterns, trends, and relationships that might be hidden in raw numbers. I encourage you to always integrate visualization into your analysis workflow to better communicate your findings and understand the underlying data distribution. So it will help you to understand your data more. You will work with your data, you will see like how much data you have in your data set, and it will help you to know your target audiences. Now we will move into our inferential statistics. Moving into inferential statistics, we begin with hypothesis testing. This method involves formatting a null hypothesis and an alternative hypothesis, then gathering data to determine which hypothesis is supported by the evidence. Hypothesis testing helps us assess the significance of our results. For instance, in validating a new feature for a model, we can statistically confirm whether the changes lead to genuine improvements. Understanding type 1 and type 2 error is key here, as they represent the risk of false positives and false negatives, respectively. Along with the hypothesis testing, confidence intervals are fundamental. A confidence interval gives us a range within which we expect the true value of a population parameter to lie. Based on our sample data, these measures of uncertainty allows us to evaluate how reliable our estimates are. Decision makers often rely on these intervals to assess risk and gauge the variability inherent in simple estimates. Effective data collection is essential for accurate statistical analysis. Sampling methods such as random sampling, stratified mode sampling, and cluster sampling ensure that the data we analyze is representative of the larger population. Employing proper sampling techniques minimizes bias and strengthens the validity of our conclusions, which is especially important when drawing inferences from the data. Now comes our interesting one, the regression analysis. When we focus on regression analysis, a cornerstone of predictive modeling, linear regression is one of the simplest yet most powerful techniques for modeling the relationship between a dependent variable and one or more independent variables. It involves estimating the parameters that best describe the relationship in the data, essentially fitting a line that minimizes prediction errors. This model provides insight into how changes in input variables can lead to changes to output. Evaluating the performance of a regression model is vital. Metrics such as R squared, mean absolute error or MAE, and root mean squared error or RMSE provide a quantitative way to assess how well our model performs. These metrics not only indicate the model's predictive power but also helps us diagnose potential issues like overfitting or underfitting, guiding us in refining our model further. Regression is not only inside, like into the smaller one, it is also in our advanced level too. As we move beyond simple linear models, advanced regression techniques come into play. Methods like polynomial regression allow us to capture nonlinear relationships. Regularization techniques, like let's say we have our ridge regression and what was the other one? Uh, the lesser regression, help address issues such as multicollinearity and overfitting by penalizing excessive complexity in the model. These techniques greatly enhance our model's ability to generalize to new and unseen data. Now comes our statistical learning, where we do the transition from traditional statistical methods to statistical learning to machine learning. One of the most fundamental distinctions in between supervised and unsupervised learning. In supervised learning, we know, my mistake, we train the models using labeled data to predict outcomes. On the other hand, in the unsupervised learning involves finding patterns and structures in the unlabeled data, such as grouping similar data points into clusters. Both approaches rely heavily on statistical methods to extract insights and make predictions. Feature selection is another critical component. Choosing the most relevant variables from a dataset can greatly improve model performance and reduce complexity. Techniques like forward selection, backward elimination, and recursive feature elimination help in optimizing the set of inputs used in machine learning models. This not only speeds up model training but also enhances interpretability and accuracy. In the context of machine learning, evaluating model performance requires specific metrics. Yes. Whether we are dealing with classification tasks where accuracy, precision, recall, and F1 score are key, or regression tasks, selecting the right evaluation criteria allows us to make informed decisions about model effectiveness. These metrics give us direct insight into where our models excel and where improvements are needed. Now it comes to wrap up. It's clear, right, that understanding and applying statistical concepts is absolutely vital in the realm of AI and ML. From building the initial framework for data analysis to refining algorithms and validating results, statistics is at the heart of every data driven solution. By mastering these techniques, we not only improve model development but also enhance our decision making processes and pave the way for innovative applications for AI and ML. Thank you so much for your attention and participation today. I hope this session has provided you with a comprehensive overview of how statistics underpins our work in AI and ML. Now, I would like to open the floor for any questions you might have. Feel free to ask for any clarifications or further details on any of the topics we covered. You can also reach out to me later through the contact details. You can reach out to me via my LinkedIn, or you can reach out to me via Facebook, anywhere. And thank you once again. We hope that no one have any questions. So we can end our stream here.